the session of remote sensing and GIS. So, today we are going to discuss a new module which is known as image processing and digital image processing, and which is also have the content of image interpretation. So, this is basically goes on the fundamentals of remote sensing, and now in this module we are going to discuss the images, the satellite images which we have downloaded, which we have produced to work on and to solve our problem. What are the techniques and tools that can be digitally applied on our image, and what analysis can be possible through these techniques? So let us discuss first of all that introduction to what is digital image processing and image interpretation. So first of all, we would like to discuss here that image which we have got from the satellite, which we have derived from the satellite sensors, needs to be properly enhanced for human eye interpretation, right? The image which I have derived from the satellite sensors needs to be properly enhanced. Then only my eyes can derive the information what I require. Similarly, digital image processing means digitally we are doing the process, the techniques applying on the satellite image through the means of computer and softwares. Third, the field of digital image processing refers to processing digital image by means of computer and by means of the various softwares. And lastly, we all know that what is digital image? Digital image is function of f, x and y with the spatial location through the intensity of gray to white, which is known as pixels, which is the smallest unit in the satellite image, right? Or in the normal image which we capture even through our mobile phones or the cameras. So this is the basic introduction to the digital image processing. What is digital image processing? What is the concept of digital image processing, and why we need to do the digital image processing on our satellite image? And image interpretation will help us to identify various numbers of analysis from our satellite image. That is basically research and development in the sector of remote sensing. Now, let us see and discuss further the characteristics of digital image. What are the characteristics of digital image? Yes, you have heard this name, that is analog and digital. Where we have heard this name? In the module that contains analog data and the digital data in spatial data analysis only. Now let us see what is the analog and digital in our digital image format. You can see here we have optical, thermal, infrared, that are the various spectrum ranges of what? Electromagnetic radiation. And through that only we are going to do the analysis. Now, I would like to say a few statements here that the term gray level means the scalar measurement, right? The scalar measurement from gray to white in the image, right? So we have the different scale in our image starting from the gray scale to the end of that comes to an white, that ranges from which to which, that is 0 to 255. Now, human eye can identify thousands of shades, and for that identification with the clear image, with the clear identification of the feature, we require to provide the digital processing on it. So, this is the characteristics. We get it from the analog and the digital things, and that is the whole spectrum range of electromagnetic, optical, microwave, thermal, infrared, and according to the image we will classify and we will do the enhancement of the image. Now, going to the next, first of all, let us understand what is histogram of an image. Histogram means here the graphical representation of image for the visual appearance. So here you can see the image which I have shown here is showing me if the brighter color histogram value will be the higher, that is the pixel value will be the higher. If the pixel value is low, that is the color of the image somewhere is lower, it is lighter, then you can see that it contains the lower pixel values, right? That is what is histogram. But histogram is important for the image because it has various numbers of colors and we can get to know the pixel intensity and information through histogram of image only. So student, here histogram, you have heard this word because this is the type in which we represent the graphs, right? But here in the context of satellite image, histograms represents the graphical representation of the image which contains the pixel intensity, right? So we can get to know the image that what type of color indicates how much pixel intensity. Now, histogram can be used for preparing thematic maps. It is used to determine the type of processing has been applied to the image, what type of processing is been applied, what type of correction is been given to the histogram from the original image can be known from comparing the histogram of both the images, and it will improve the visual appearance of image. Now, let me take and show you other example. You can see here I have shown the red, green and blue color, and through the graph it is more clear. You can see the image which I have opened. I have opened the histogram graph of it. Now you can see the pixel intensity of various region in this area which I have selected. So you can see which color has more intensity in the image. So we are now going to apply the tools, that is the digital image processing or the image interpretation will depend on the histogram of image, and that is why to understand histogram is important before going into the digital image processing. So now let us see the first of all image and resolutions, which are the various types of image and resolutions, right? That can be said as image resolutions. We have various numbers of resolutions. We used to see and search that this, for example, this mobile or this brand has this much resolution for rear and the back camera and the front camera. Similarly, the satellite image sensors also has the typical type of image resolution. And to understand the satellite image resolution, we need to know the characteristics of the satellite image resolutions. So first of all, let us see which are the types of resolution. The first type is known as spatial resolution. The second type of resolution is known as spectral resolution. The third type is temporal resolution, and the fourth is radiometric resolution. These are the technical terms related to our satellite image, which are the resolutions of that image. Now spatial, we all know that location based resolution. Next is spectral. Spectral means numbers of multi-bands, numbers of colors, spectrum, that is spectral. That is known as spectral resolution. Means image consists how many bands and that bands shows us which information. Next is temporal. Yes, we all know that the frequent repetitive images is known as temporal resolution. And last is radiometric, right? How much bit of image and how is the information we can extract is radiometric. We need to understand this in detail because these are the resolutions which we have to enhance by the tools and applying it on the satellite image, and that is the process which is known as digital image processing. So we are going to discuss these imaging resolutions in detail. First of all, let us discuss about the spatial resolution. Spatial resolution might be clear by looking to the image which I have shown here. You can see here I have shown the image which is taken from the sensor for 1 meter, 10 meter and 30 meter. You can see here in 1 meter area is covered more, but you cannot properly demarcate the feature. Yes, you can demarcate the feature, but area is covered more. Similarly, looking to 10 meter and looking to 30 meter. 30 meter is so much zoomed in that we cannot get the proper information. But yes, you can see here that we can get the pixel intensity very properly in this. As you can see here, the various pixels are shown here. Now, you can see the very left hand side image of yourself and that is, you can see I have shown here the low and coarse resolution image. Yes, area is covered more, but features cannot be demarcated. Large features are visible, but small features are not visible, and that makes our image, when we count the pixel intensity, it will mix up and it will give us a noise and it will give us a wrong pixel intensity, and we cannot enhance that pixel intensity properly for the analysis portion. And similarly, I have shown here fine and high resolution image. You can see here even the small features are very properly seen into it. So here, basically spatial resolution says us that minimal detectable area on the ground by the detected placed on the sensor is called spatial resolution, right? The sensor has a capability to get fine and low, high and coarse resolutions, and according to the resolutions we can have the feature identification, which is known as spatial resolution. Now, let us see the important topic which is known as pixel size and scale. What is pixel size and scale? We all know that remotely sensed image are made up of pixel, which is the very smallest unit of image. And it is important to distinguish between pixel size and the resolutions. We will take here the spatial resolution because they are not interchangeable. Now, how can we identify the pixel size and scale, right? First of all, what is IFOV? I have written here IFOV may be defined as the area on the ground which is viewed by a single instrument which has some altitude and at the instant of time. Now, IFOV is instantaneous field of view, means at the time when satellite is capturing the image and how much image at which height it is capturing, which is known as IFOV, right? So according to that, we can see the pixel size and scale. Now, if a sensor has a spatial resolution, for example for 20 meter, and image from a sensor is displayed at full resolution of 20 into 20 meter on the ground. So what is it saying? 20 meter of resolution and 20 into 20 meter of pixels of that area we can see. So similarly, if I say, we all know that map and scale representation, which is been explained here. So you all know that maps or images with small scale to ground ratio are referred to as small scale, and those with larger scales are referred to as large scale. So if 1 is to 1 lakh is having the small features, is covering the large area, but features are small. And when it is 1 is to 5,000, we'll have the good quality of small features and we can detect the small features very well. So depending of our analysis and research, we can change the pixel size and scale. So student, here this is important topic regarding the pixel size and scale because IFOV is a new terminology for you to understand for satellite image. So here pixel size and scale plays an important role during the spatial resolution imaging resolution for the satellite image. Now, so basically, according to the resolution, according to spatial resolution, we will be demarcating the features. 1 meter, 3 meter, 5 meter, 10 meter, 30 meter. Various sensors and satellite have various resolutions, right? So let us now discuss what is spectral resolution. Yes, the name itself suggests the number of bands has the number of informations into it which will be capturing the different feature. If a sensor has 8 bands inbuilt, then in 8 various bands the image will be capturing each feature, right? Understand this, spectral means number of bands, right? And number of bands various bands have various information. So if for an example, I want to know the information related to the water body, then I can get it from the band number 2 or for example band number 3. So while capturing the whole image of that area, sensor will capture all the water body in band number 8 or in band number 3 as per prescribed when making the sensor. Similarly, if I want to know the urban area, if I want to know the vegetation, if I want to know the forest area, if I want to know where is the construction of canals and rivers and linings can be known through the various band information, which is known as spectral resolution. But how do we know that which band says us which information, right? How can it be done? Now, let me show you here one example. You can see the image what I have shown here. Yes, when I open the layer property of the image which I have opened will show me the numbers of bands inside it. And according to my requirement, I will change the combination of bands. So various sensors has various band combination. So here, if I want to, for example, know the information related to vegetation, then I need to do the probable combinations of the band and I will able to see the image who has major number of vegetation into it. So this is about spectral resolution, right, which is according to it very sensitive to capture the data because electromagnetic radiation wavelength to which it has width of segment or bands of electromagnetic spectrum into it. Increasing spectral resolution, the potential of system to demarcate between feature is improved. So when we have a good combination bands, when we have a good probability band combination, features are goodly and are properly seen and demarcated. As I have told even before that we need to do the band combination and we can extract the information of our features. So this is about the spectral information. Now going to the radiometric resolution. Yes, you can see the images and images can tell you what is the difference behind radiometric resolutions. So first of all, let us see the capability of sensor to demarcate or measure the smallest reflectance of energy. E1, higher the radiometric resolution, smaller the radiance difference that can be detected between two targets. It defines the number of discriminable signal levels. E1, ability to discriminate between very slight difference in energy. And lastly, finer radiometric resolution, more sensitive, it is for detecting smaller difference in energy. So basically, technically, radiometric resolution says us that good resolution will give us good demarcation. What is that? If I have the 8-bit image or 4-bit image, 4-bit will contains 2 or 3 layers of colors or 2, 3 or 3 layers of gray levels. So it will not give me a proper color in the images. But if I have 8-bit image, then it will be containing 256 layers of colors, various shades of colors from gray to white, and it can show me good features. So you can see here in both the image I have shown the 2-bit data and the 8-bit data, and you can see how is information can be demarcated. Similarly in 8-bit and even in 4-bit. If you can see with your eyes minutely in the 8-bit image, the properties of the image which is taken is been clearly demarcated. The small features are clearly demarcated. See here very properly that how is small features demarcated, and that is what is the 8-bit and 4-bit. Even in 4-bit you can see, but the pixel values and the pixels are clearly visible in 8-bit, which is known as radiometric resolution. So what all I have explained is been written here in the technical portion. You have to remember the technical portion behind radiometric resolution when it is asked for the explanation, right? So more number of bit will contain more number of layers of colors and it will be giving us good information, good pixel intensity and good feature demarcation. Now, the last is temporal resolution. What is temporal resolution? Basically, temporal resolution says us the image is repetitively taken. If it is not frequently taken, it will be having low resolution. If it is frequently taken, it will be having high resolution. So temporal means temporarily we are doing the analysis of any portion by taking the image through various numbers of sessions. Now, basically, the three things related to temporal resolutions, we can say that the analysis can be done on the daily basis, it can be yearly, it can be monthly, as per your requirement in your study area. And it is for the crop growth or the stress can be known by doing the temporal analysis. Even urban growth, if I want to know, then the repetitive period is of 1 year. And lastly, all the sensors has that repetitive period. Means in a how many days sensor is completing its rotation. If I talk Indian Remote Sensing Series, that is IRS, has a repetition of 22 days. So after 22 days, it will start its rotation again in the orbit, and that is the repetition period of it. So as and when I require, I need to order the data in NRSA with the requirement of repetition. So basically, I want to know the temporal analysis. If I am doing the crop analysis and I want to know after 6 months what is the condition of crop, then I require the temporal resolution image. That is, it is taken in June, then it is taken in April, or then it is taken April next year, and then it is taken again in December. So I can know the crop growth pattern. This is just an example I am giving. Now, looking this image, the first image on the very left hand side, that is the red color showing more, that is a 2000 year image, that is the year in 2000 this image was taken. And similarly, of the same area in 2011, image was taken by the sensor which is known as Landsat, right? So in this you can see the feature is so much variation, and the analysis of image itself shows that there is a very much of temporal repetitive is being shown, and the analysis shows us that red color is of whole vegetation and it is being changed to the urban, if you can see it clearly, right? Yes, we are going to see how is this being shown, that is red is what is vegetation and here what is urban, we are going to see. But with the same sensor, but with the time interval of 10 years, you can see what is the change in it. This is specially for the urban areas. Yes, 1 year I have told that is the minimum thing which you need to do. But we can do, if I want to do the maximum analysis related to vegetation or urban, I need to take a large span, and I have taken here for the 10 years data. Now, you can see here the monthly wise analysis I have shown. Yes, this shows us the repetitive one, that what is the analysis and changes coming into that area, which is also known as temporal resolution. So basically, temporal resolution required the major image which contains the changes into it, the month, the year, or the daily basis. You can see here the monthly analysis I have shown here in the image, and you can demarcate the changes very well, which is known as even the time series changes, right? So these are the resolutions related to the satellite image, and we need to understand these resolutions very importantly and in detail, because depending on these resolutions we are going to apply many changes into it, and we are going to process that images in digital image softwares. So resolution related to histogram and what is digital image is cleared here. Thank you.